Maharashtra State Board 12th Mathematics and Statistics, Arts and Science, Part 2, Chapter number 1, Differentiation. Your introduction. Note first, that is the definition. Definition of the differentiation. The process of finding a derivative is called as differentiation. The differentiation is nothing but the process of the finding the derivative, called as the differentiation. Here, note second, derivative of a function f of x. Here consider here y is equal to f of x, that is any function of x. Then let delta x, delta y be the small increment in a variables x and y respectively, with delta x which is not equals to 0. Here delta x and delta y be the small increment in variable x and y respectively, with delta x which is not equals to 0. Therefore, y plus delta y is equal to f of x plus delta x. Okay, delta y, that is the small increment in y, delta x, that is the small increment in x. Therefore, delta y is equal to f of x plus delta x. Now take this y in right hand side, means here minus y. Therefore, delta y is equal to f of x plus delta x minus from equation number 1. Here y is equal to f of x. Put this value, y is equal to f of x. Therefore, f of x, okay, here by using equation number 1. Now this is the value of delta. Delta y is equal to f of x plus delta x minus f of x. This is the value of delta y in terms of x. The ratio delta y upon delta x is here delta y value. Now this is the f of x plus delta x minus f of x divided by here delta x. This ratio is called as incrementary ratio. Now taking limit on both sides. Taking limit delta x tends to 0. Therefore, limit delta x of delta y upon delta x is equal to limit delta x tends to 0 of f of x plus delta x minus f of x divided by delta x. If above limit exists, then limiting value is called as the derivative of a function y with respect to x, and it is denoted by dy upon dx or y dash or f dash of x. Is a derivative of y with respect to x. One remark, dy upon dx is equal to limit delta x tends to 0 of delta y upon delta x. Now this is called as Leibniz notation. for derivative, or second, here dy upon dx is equal to, here limit delta x tends to 0. Here put delta y upon delta x, that is incrementary ratio. Here we know that delta y upon delta x, that is f of x plus delta x minus f of x divided by delta x. That is f of x plus delta x minus f of x whole divided by here delta x from incrementary ratio. Now this is called as first principle formula for finding the derivative. Suppose here put delta x is equal to h, then above formula becomes f dash of x or dy upon dx. दोन्ही नोटेशन कसे सेमच आहे. here limit, here h tends to 0 of f of x plus h minus f of x divided by h. This is second notation of f dash of x. Now this is the derivative of function with respect to x. It is also called as first principle formula for finding the derivative. Third remark, right hand derivative r of f dash of x, right hand derivative, here limit h tends to 0 plus right hand side derivative, therefore here use notation 0 plus of f of x plus h minus f of x divided by h, right hand derivative. Then left hand derivative, L of f dash of x, L means left hand derivative, here limit h tends to 0 minus of f of x plus h minus f of x divided by h. This is right hand side derivative and this is left hand side derivative formula. If right hand side derivative of a function is equal to left hand side derivative of a function, then f of x is a differentiable function. Suppose right hand side derivative of function which is not equals to left hand side derivative of a function, then f of x is not differentiable, function. Right hand side derivative and left hand side derivative both are equal, then f of x is a differentiable function. And if right hand side derivative and left hand side derivative are not equal, then given function means f of x is not a differentiable function. 4. If f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x divided by h, now this is called as derivative of f of x with respect to x. Suppose here put x is equal to a, then f dash of a is equal to limit h tends to 0 of f of a plus h minus f of a divided by h. This is called as derivative of f of x at x is equal to a. This is derivative of function f of x at point a. Here second notation, that is here dy upon dx means derivative of y with respect to x at point x is equal to a. Fifth, notations for derivative. Here dy upon dx is here derivative. Second notation, f dash of x, that is derivative, or y dash, now this is also derivative, or here y1, now this is also derivative. Here different notations are used for derivative. Here dy upon dx means derivative, f dash of x means also derivative, y dash also derivative, and y1 also derivative. Then 6, dy upon dx. Now meaning of this dy upon dx, that is the derivative of y with respect to x, or that is the rate of change of in function y at point with respect to variable x. Now this is the dy upon dx. The dy upon dx means derivative of y with respect to x, or the rate of change in function y with respect to variable x. परत एकदा ओव्हरलुक करूया. Differentiation. The process of finding the derivative is called as the differentiation. Derivative of f of x means, suppose here consider y is equal to f of x. Let delta x delta y be the small increment in a variable x and y respectively, with delta x which is not equals to 0, y plus delta y, and here x plus delta x. Delta y and delta x, that is the small increment in variable y and in variable x. Suppose here take this y in right hand side, here plus convert into minus, then f of x plus delta x minus f of x from equation 1. Here we know that y is equal to f of x, means here put y is equal to f of x. Now this is the value of delta y. The ratio of delta y upon delta x is called as the incrementary ratio. Now this ratio is called as the incrementary ratio, but here delta y is nothing but f of x plus delta x minus f of x divided by here delta x as it is. This is called as the incrementary ratio. Suppose you are taking limit delta x tends to 0 on both sides. Your limit delta x tends to, here delta x tends to 0. Delta y upon delta x is equal to, here take limit delta x tends to 0 on right hand side, f of x plus delta x minus f of x delta x. If above limit exists, then limiting value is called as the derivative of the function with respect to x. ही जर लिमिटिंग व्हॅल्यू एक्झिस्ट होत असेल तर ह्या लिमिटिंग व्हॅल्यूला काय म्हणणार आहे, डेरिव्हेटिव्ह ऑफ अ फंक्शन विथ रिस्पेक्ट टू एक्स. इथं फंक्शन वाय यूज केलेलं आहे, म्हणजे डेरिव्हेटिव्ह ऑफ वाय विथ रिस्पेक्ट टू एक्स किंवा डेरिव्हेटिव्ह ऑफ फंक्शन एफ ऑफ एक्स, अँड इट इज डिनोटेड बाय dy upon dx or y dash or f dash of x. हे तीन डिफरंट नोटेशन वापरले जातात डेरिव्हेटिव्हसाठी. तर रिमार्क फर्स्ट, dy upon dx is equal to limit delta x tends to 0 delta y upon delta x. Now this is called as Leibniz notation for derivative. Here put delta y upon delta x, that is the incrementary ratio from this equation. Suppose here equation number 2, that is delta y upon delta x in terms of f of x, means here f of x plus delta x minus f of x divided by delta x, and now this formula is called as the first principle formula for finding the derivative. Suppose here put delta x is equal to h tends to 0, and here put h, here also h. Remark 3, right hand derivative किंवा right hand side derivative r of f dash of x, means here right hand side derivative limit h tends to 0 plus f of x plus h minus f of x upon h. Now this is the formula for right hand side derivative, and left hand side derivative, here use L f dash of x is equal to limit h tends to 0 minus f of x plus h minus f of x divided by h. If right hand side derivative is equal to left hand side derivative, then f of x is a differentiable function. If right hand side derivative which is not equals to left hand side derivative, then f of x is not a differentiable function. कंडिशन येत असेल तर फंक्शन काय असणार आहे, नॉट डिफरन्शिएबल असणार आहे. इक्वल असेल तर डिफरन्शिएबल, नॉट इक्वल असेल तर नॉट डिफरन्शिएबल. रिमार्क 4, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Now this is formula for derivative. डेरिव्हेटिव्ह फाइंड आउट करण्यासाठी आपण हे फॉर्म्युला यूज करणार आहे. याला फर्स्ट प्रिन्सिपल फॉर्म्युला म्हणतात, डेरिव्हेटिव्ह ऑफ एफ ऑफ एक्स विथ रिस्पेक्ट टू एक्स. सपोज here put x is equal to a, then here put x is equal to a means f dash of a. Suppose here put x is equal to a means here f of a plus h minus f of a upon h. Now this is the derivative of function f of x at x is equal to a. Second notation, that is dy upon dx, means derivative of y with respect to x at point a. जर त्यामध्ये x इज इक्वल टू ए पॉईंट पुट करत असेल तर आपण इथे मेन्शन करणार x इज इक्वल टू ए, मीन्स हियर डेरिव्हेटिव्ह ऑफ y विथ रिस्पेक्ट टू x ॲट पॉईंट ए. रिमार्क 5, डिफरंट नोटेशन्स फॉर डेरिव्हेटिव्ह. हियर फर्स्ट नोटेशन dy अपॉन dx, सेकंड नोटेशन f डॅश ऑफ x, थर्ड नोटेशन y डॅश अँड फोर्थ नोटेशन y वर. हे सगळे डेरिव्हेटिव्हचे नोटेशन्स आहे. रिमार्क नंबर 6, dy upon dx, that is the derivative of y with respect to x. याचा मिनिंग काय, dy upon dx म्हणजेच काय, डेरिव्हेटिव्ह ऑफ y with respect to x. okay, dy upon dx, that is the ratio, means here the rate of change in function y at point with respect to variable x. है ना, जे y चा डेरिव्हेटिव्ह with respect to x यूज करतोय. the rate of change in function y with respect to variable x. Thank you.